Hello, everyone, and welcome. It's a pleasure to have you here for today's masterclass, AI Clash Classifier, Transforming BIM Coordination with Machine Learning. Thank you for joining us. In today's session, we will explore how AI is shaping the future of construction technology. So get ready to dive in. And my name is Thaisa Figueroa. I'm Institutional Manager and Program Owner here at ZIGURAT, and I'm really excited to be your host today. And for those who may not be familiar with us, ZIGURAT is an online education institution with over 20 years of experience in e-learning. We offer master's and postgraduate programs in architecture, engineering, and tech management, helping professionals worldwide advancing their careers. And we are proud of our diverse and dynamic community with more than 20,000 students from 120 countries. And before we move forward, let's try to make this session more interactive. We want to hear from you, so please share with us in the chat, where are you joining us from today? Let's make this an engaging and dynamic experience together. Sorry. And now I'm super pleased to introduce our esteemed speakers today, Renata Gomes and Thomas Takeuchi. Sorry. Renata is a BIM coordinator at Nuno Leónidas Arquitetos in Portugal. She's also ZIGURAT alumni and an architect focused on building information modeling and artificial intelligence for the AEC industry. And Thomas Takeuchi is co-founder and CEO at Arquigen, a company in Brazil, professor at ZIGURAT, and an expert in parametric architecture, generative design, and BIM. Before I pass you the floor, a quick note for our audience. If you have any questions, drop them in the chat, and we will, during the Q&A session, we will address them during the Q&A session at the end, okay? And now, let's welcome Renata Gomes and Thomas Takeuchi. Renata will introduce AI Clash Classifier, an intelligent solution developed by her team during ZIGURAT's postgraduate program in AI for construction, under the guidance of Thomas Takeuchi, professor and mentor of the team. Renata, thank you so much. A pleasure to have you here. And it's over to you now. The floor is all yours. Thank you.
Thank you very much, Thaisa. Very happy to be here and honored to be called to talk in this masterclass. Are you guys hearing me well?
Yes.
Okay, so let's start. So hello, everybody. I'm Renata Gomes, and I'm very happy to be here today to talk to you about my group's final project from ZIGURAT Postgraduate Programme in Artificial Intelligence Applied to Construction. I'm currently BIM coordinator at Nuno Leónidas Arquitetos in Portugal, and I've also done the ZIGURAT's Master in BIM Management. And I'm here today to present to you the AI Clash Classifier, our AI model for BIM coordination optimization, developed by me and my group colleagues Bruno Fernandes, João Fonseca, Anastasia Turash, Christian Valentin, and Flávio Antunes. The first thing that our group knew was that we wanted to combine AI and BIM in our final project. And to explain why this combination has so much potential, I will quickly differentiate the main working methods in architecture. Originally, projects were made with paper and pencil, then the pencil turned into its digital version called CAD, computer-aided design. And now we are able to make projects in building information modeling. Here we have a simple apartment floor plan made with CAD method. I consider CAD method as a digital version of the pencil, and I say that because, for example, when we see this floor plan and we click, for example, in this door, the software recognizes a line. When I click on the door opening, it recognizes an arc. And here, when I click on the wall, it understands it's an edge. And what gives meaning to these floor plans is the human interpretation of those geometries. The software itself, it's not aware of the architectural categories inside here. Here we have an office building made by my group during our master in BIM management. And unlike in CAD projects, when we click on the elements, we can see that embedded within these elements, we have information like, for example, this is a curtain wall. We can see that this is furniture tables. This is a seating, and for example, this is a column. So it is possible to embed information inside the elements, and that gives it so much potential for building data sets over it. Another advantage of BIM is that it is possible to analyze the project. It's possible to analyze all the disciplines inside the project. See, we can have those overlapped and look for mistakes before the construction phase. So it's also very interesting for that. Among the different possible BIM uses, project coordination is one of the most used in order to evaluate different disciplines compatibilizations. A clash detection is the main method to identify collisions in between project disciplines, and each collision is represented by a line in a long report that contains all information we want about the elements involved in the clash itself. The challenge within this resource is that the amount of information we are able to get out of this can be very extensive, which means that someone will have to interpret manually each one of those numerous clashes identified by the clash report, which lead us to our project scope. A clash report, as we saw, is a list of collision in between elements of different project disciplines. The problem is that this list can be very extensive, which means that architects and engineers must carefully interpret each clash one by one. And this process can either be time-consuming when done thoroughly, or it may be rushed, leading to potential errors down the line. And the main idea is, since artificial intelligence is very good at processing and interpreting large data sets, we thought about using it to go through those very long clash reports and help designers by prioritizing each clash. AI won't discard any clash, but will indicate how urgent might each one be, so that the designers can address critical issues first and lose less time with low priority ones. In order to do so, and considering the complexity of the whole problem, we decided to focus on delivering a minimal viable product, an MVP, which means addressing a specific yet important aspect of the issue to ensure that all efforts are both practical and manageable within the project's timeframe. Our MVP consists on resolving clashes between beams and pipes. We chose this specific type of clash because it is easier to categorize with minimal ambiguity. With the assistance of structural engineers, we've mapped out the beam's vertical surface and divided it into 3 priority zones. The red zone, high priority. A clash in this area is strictly forbidden. The yellow zone, medium priority. Not ideal, but acceptable. Green zone, low priority. generally permissible. Now you might be wondering, why use AI and not a filter or a simple script? First, simple filters or rule-based scripts can only work with structured data, like spreadsheets and retrievable parameters. This research input consists on both structured data, the Clash report spreadsheet, and also unstructured data, the Clash images that comes within it, which is ideal for artificial intelligence because AI is better suited for handling semi-structured data. See, here I've put an example for you to better understand what unstructured data and structured data means. Unstructured data, for example, can be a note on your fridge remembering you to buy some things at the grocery store. Structured data would have those items categorized, the quantity, the category, the price of each item. So these are different ways of organizing information, and the structured data is easier for any type of computer to understand. But AI is also able, via training, to understand unstructured data, like images, for example, also. Second reason why AI and not a filter or a simple script is that rule-based systems require manual updates whenever the data or context changes, making them unable to adapt to new inputs or evolving conditions without time-consuming human interventions. And here I put an example of a project where you want the clearance zone of your fire exit to be free of any obstruction. So here we have a chair, which is not worrying. But for example, if you have set the filter to look for furniture and this chair is a generic model, then the filter might not work. You won't have the flexibility to understand it's also important not to have this regardless of the category here. And for example, if you change the name of the door, you gave it to the filter, or for example, the filter might not understand that another door close by could be a problem for the clearance zone when it's opened, since it might only understand the door as a closed object. Those are just a few examples of how context can change and how when this context change, there must be a human there to update the filter or the script. Third reason, AI capacity to learn and evolve over time ensures continuous improvements in accuracy as it processes new data and experiences. This flexibility helps AI remain relevant as businesses evolve. Now let's talk about the dataset creation using BIM softwares. At first, we started out modeling the elements of our MVP diagram, the columns, the beams, and the pipes. We also made a beam family that would behave like the MVP, with these green and yellow areas for us to better understand which type of clash we had for manual classification. So each pipe was manually classified here with an L, an M, or a high. After that, based on where the pipe would be pierced, we would manually classify it, as I said. And those will be our target data, our correct answer, to then compare to the AI answer. After that, after we came to this, we multiplied this by a lot of pipes and a lot of beams so that we would have more, a larger data set for training, more robust one. Some parameters were needed, for example, the centroid of the elements, for example, the beams. I'll try to open Dynamo to see if I can show you how we came up to this value. So this is a simple script. We made a routine in Dynamo. Let's run this. So, okay, it went well. Here we have the geometry the routine recognized. Here we have the routine. So here it's calling for the beams itself. We can hide this, and then this will get the point out of the solid we selected. So these points are turned into coordinations that are inserted in the centroid parameter. So we found that this information would be very interesting input for our training. Okay. So these models are then imported into Navisworks, where it is decided which type of information regarding the clash and the involved elements should be included in the clash report. First, we import the models, then we activate the clash detective. In the select tab, we pick the two elements that the program should look for when listing the clash, then set the clash tolerance so as to avoid false positives. Then in the results tab, we can get the full list of clashes found, and we are able to see each one as we click. And then in the report tab, we can choose the information we want to in our report and then export it. So our report will look like this. This is the HTML file we get after running the clash detection. For the clash itself, we have its image, name, and geometrical location as XYZ coordinates. For the beams, we have its ID code, its category, and also its height, the bottom height, and the centroid coordinates. And for the pipes, we also have the ID code category, but also we have its diameter, its middle elevation, the priority parameter that we manually classified here, and the coordinates of its centroid as well. So the first step of any machine learning training process is dataset gathering. In our case, it begins by extracting input from the Revit models, which contains Revit families, Dynamo routines, and manual classification. Then inside Navisworks, every clash is listed along with the selected parameters mentioned earlier, and the result HTML file and image folder then serve as basis as for further script refining. It's our dataset. Now we are entering the processing phase where we will get this dataset and make it more clean and purge it so that the machine learning can read it better with less noise inside it. So now we are coming to our code. So first thing, we will import our clash report as HTML file. Let's do this. It will ask us to browse. So I will browse it. HTML file. Then this will load the HTML file, turn it into a CSV file, which is more readable for machine. And then it gives us a preview of what it's reading. So you see that information here is kind of messy. We have, instead of the images, we have its path. We have the coordinates here that are not very well structured for machine understanding. And the headers here, we could make it more understandable. So that's what we are going to do. We are going to have a script to adjust the headers. So I'll play it. Then we already see some differences. We only have the image name, we don't have the image path. Here it differentiates when the information is categorical and when it's numerical. For instance, this value is an ID. The program should not read it as a numerical value. It's here to categorize, so it's categorical data. You shouldn't waste time thinking it's numerical. And also, we create more columns so that we can structure better the coordinates we received. And finally, the target data is written target data here so that it's evident. Then we are going to calculate the distance between the clash point, the coordinate of the clash point, and the beam centroid. We found that this information would be more relevant than giving a lot of coordinates. So the more information you give, the more it can get lost as well. So here we make those calculations are inserted, but then we have too much information here, so we purge the unnecessary information. Now we have a cleaner schedule. Now that we have our data set cleansed, we are going to split this data set into 6% for training, 20% for validation, and 20% for final tests. Because in order to have a successful training, we can't use our whole data at once. So we are going to split this. I already done the image import because it takes a while. It's a lot of images. Okay, the split is done. You see that as long as I click on as I run the scripts, the data it's creating, it's accumulating here. Now there's a script to pre-process the data. This is the final script before training that will process and refine our data to make it more readable for machine learning. What it makes is that the numerical columns are cleansed of non-numerical characters. The categorical data is one hot and colded. Images are resized and associated with each clash. Now, it's saying it didn't found the images because I ran out. I have to load the images again, but I won't do that. Let's do that while I explain another thing. Let's come back here. Let's load the images while I explain something else. Okay, coming back here. So the second stage of our project, dataset refining workflow, involves converting the HTML file into a CSV file, then adjusting the columns and structures and headers into these three scripts. Then we can have it clean for our dataset split, where we have a bigger amount for training, then 20% for validation, 20% for test. And then we have the dataset process where we get all of this and combine with the images. Now let's talk about the AI training code. First, we import the necessary libraries like TensorFlow for neural network training, the scikit-learn for further preprocessing and model evaluating, and also NumPys and Pandas. Then the label encoding part will transform each parameter into a numerical value and adjust the class weights to address imbalances in training. Then this part of the code shows that the model's architecture is set with two sections, one for non-image data and another for image data. Then it combines and supplements those sections with a dropout layer, here, a dropout layer, to prevent overfitting. And its training then is prepared with an atom optimizer to improve its performance. Then finally, the model is set to be training for 20 epochs, an epoch being one complete pass through the whole training data. Let's see if our code loaded the images here. Let's see, it's 61%. So while that is loading, I'm going to talk about something else. The workflow of the AI training consists on inserting the pre-processed training dataset as an input for the training script, which will then ask if I want to load the model weights to get incremental training. If none are loaded, then it will start from scratch, and the final output will be an AI model, the session's model weights file that can be used if I want to train it again and I want to be an incremental training, and then the training evaluation file. AI testing. To verify if the training was successful, this workflow inserts two steps, the validation and the final testing. The code is exactly the same for both. The difference is in the input dataset. We can test our model with the validation set. Then after evaluating the metrics, we can adjust the training definitions and further train the model so that we can have a final test with unseen data from the final test dataset. This is our output. After running the test code, we get an Excel schedule with the report information alongside the target data, which are the correct answers, the parameter that we classified in Revit. Each pipe is here, the correct answer, and this is what the AI predicted. No, the AI cannot cheat and see the answers, so that if you're wondering. So see here, it got it wrong. But we don't have to analyze this whole Excel to understand how well the AI prediction went, because we have our evaluation performance metrics. But before that, let's see if that's loaded. Yeah, 100% done. So let's try again this. This will load a little bit. So it will show this message 3 times because it's making the training set, validation set, and test set. Okay. Now I'm going to start the AI training script. It's asking me, do I want to load the model weights? For now, no. If I had trained this before and had the model weights, yes. But I'll say no, and it will start from scratch. Remember, I told it's set to have 20 epochs, so it will pass through the whole data 20 times. Here you can see it thinking. And each time it gets different results for loss, accuracy. And you see the accuracy tends to get higher and the loss tends to get lower. So this is what training looks like. It's thinking through the whole data. Almost done. Okay, it ran 20 times. Now it's going to generate our metrics. After we have this, we have different metrics to evaluate. We have this, we have the confusion matrix, we have the hot rock curve, and we're going to talk about those right now. So the training report evaluates training accuracy and loss. Our training session reached 88% of accuracy rate, which is a good result, but the fluctuations in the graphics, meaning this, indicates overfitting. which happens when the training results are better than the validation results. So to try to explain it a bit better, in this graph, we have the training and validation accuracy in this graph and the loss in this one. And this is the value of the accuracy or the loss, and these are the epochs. So this represents the values between all the 20 epochs we just saw happening. So accuracy was elevated and loss was reduced. But the differences between the training and the validation inside the training script are big, which means a bit of overfitting. Another metric we have is the classification report, and it also indicates overfitting since the training accuracy is 92%, as we can see here, and it's higher than the validation, 87%, and the final test, 88%. So it's good at training, but when it comes to the final test, its efficiency gets lowered. That's where we can make it better, although 88% is a good result. We have this metric, which is the confusion matrix, which is interesting to understand better where we got it wrong. So in these graphs, we have on top what the AI predicted, and we have on the vertical side what were the actual answers. For example, in the training, 0 means high, 1 means medium, 2 means low, which means that 1,536 elements were rightly categorized as high by the AI. 543 were correctly categorized as medium, and 135 were correctly categorized as low. And the other values we see here is where it got it wrong. And we can understand how it performed during training, validation, and final test. Since the training dataset was bigger, it has higher values, just so you know. Now the ROC curve, it's a bit similar. The higher this space we get here, each line represents the categories, 0 high, 1 medium, 2 low. The bigger the area we have here, the better are the results. And the differences between the lines also indicates the differences between training, validation, and final test. And now we can evaluate this solution just presented. Our solution domain is inserted into the design phase of the project. It's an evaluation model rather than a generative one with a classification purpose. In terms of AI category, our model fits into the machine learning because it utilizes algorithms to enable autonomous learning, fits into the deep learning due to its use of convolutional neural networks to process complex multi-layered datasets. It went through supervised learning because it was trained with labeled datasets. It's discriminative model because it focuses on identifying the boundaries between different classes. And its main point is to predict categories. So the conclusion of the project is that the project aimed to improve the management of clash reports in construction by prioritizing clashes in AI, initially focusing on BIM and pipe clashes through a minimal viable product approach. This helped lay groundwork for future developments. The AI model integrates machine learning, deep learning, specifically using convolutional neural networks to analyze dual branch datasets consisting of both image and non-image data. It operates under supervised learning, leveraging labeled data to improve prediction accuracy as a discriminative model, and it focuses on accurately predicting categories based on input features, essential for enhancing decision-making in construction management. The project demonstrates how AI can enable innovation, even for non-experts, like my group was not expert in programming. And by allowing the team to build an effective AI model despite its limited technical expertise, showcasing the potential of AI in advancing technology across the architectural, engineering, and construction industry. That's it. Thank you.
Really nice, Renata. Congratulations. Thank you. Thank you so much. I don't know if Thomas wants to talk something or do some comment. Feel free, okay, Thomas? If not, I will keep going. So thank you. Thank you so much, Renata and Thomas. The work you have developed in just 4 months is truly impressive, demonstrating how AI has the potential to revolutionize the architecture and construction industry by streamlining process that previously required extensive time and resources. So congratulations, Renata, your team,
Thank
and
you.
also Thomas for this outstanding achievement. And now let's keep going. Let me get back my presentation here. And speaking of getting ready for the future of construction technology, today's session is directly connected to our newest launch, the ZIGURAT Masters in AI for Architecture and Construction. And to tell us more, I'd like to invite now Lilian Ho, the Master Director at ZIGURAT. Lilian is being a digital lead in the AEC industry with over 20 years of experience in BIM management and digital construction. And Lilian is specialized in data-driven design, automation, and AI-driven workflows to transform the industry. Lilian, thank you to be here with us, and the floor is yours now.
Hi there, thank you for joining us this afternoon. My name is Lilian, and I'm the Program Director of ZIGURAT Institute of Technology, and I will be leading this first master degree course in Artificial Intelligence for Architecture and Construction. And welcome to this section, as well as Taisa say, like, my background is architecture and BIM and digital, and I'm in construction for a while, and throughout my career I work on a lot of public project, private project, and a security project, non-security project, massive data, and also provide the digital consultation as well. And my interest is for the advanced technology, automation, obviously the AI, and how to use the AI to drive the efficiency and innovations in AEC industry. And so you might notice there's AI have been rapidly involved in our life over the last few years. And the pace of the AI development is accelerating. Within a year, 3 new generation of powerful AI models have been released and flooding all the products and projects initiative to the market. These advancements to using AI and is valuable tools to improve the efficiency, more safe on-site, overall performance as well. And as the AI technology continues to evolve, and our adoption and impacts for the AEC industry is only growing, and that need more innovation and more sustainable construction practice as well. I mean that we embrace the AI, and not just the option now is necessary for the AEC industry or individual professional looking to stay more competitive in the market and in this increasing digital world. So at ZIGURAT, we are very concerned for the latest trend possibility for the future. We decided master degree course, and we try to meet the future need of the AEC industry and prepare the future leader for AEC labor market. The duration, I see some of the question as like, oh, how long of the course, and the durations of this course is 1 academic year, and it will be conducted live online in English by myself and other professor. Okay, and it is cover fundamental aspect of digital transformation through AI. For example, like generative design, BIM, machine learning, the digital twins, and much more. And each area, you will gain a lot of like in-depth knowledge. And also, I saw some of the question. They say like, do we need to have a coding background? No, you don't need to. As long as you have a heart to learn, and that's it, and that can progress. So if you want to know more information, and yeah, you can see the website, and that the next slide, please. Yeah. Yes, so this master degree course is divided for 4 blocks, with the final master degrees project. And the first block is, you can see it from the screen, as a computational logics and AI fundamental applies to the AEC sector, and which is included 3 modules. And the first module is fundamental AI for AEC, and the second module is computational logics and programming, and then the third module is the AI application and digital development. And the second block and the key area of AI is applied to the AEC sector, and we included 2 modules, and the module 4 is a program and AI for AEC, and then the 5th module is the AI in project automation and innovations of ethics as well. And the third one is a BIM and generative design empowered by AI. And you can see that it's the 2 modules. And the 6th one is the integrations of AI, generative design, and BIM for innovation. And the 7th module is AI and BIM for intelligence construction project and process management as well. And the final one is the 4th one, and a disruptive technology from building to smart city. And this included 2 modules. And this is included for the module 8 is included the disruptive technologies in construction and digital project management. And the 9th one and the final one is a digital technology management for smart city and intelligence construction. And then you will have the final master degree project as like Renata and Thomas, and have the group projects. And it's focused on the creating AI-based solution for building infrastructure, urban planning project. And students will work in a group and then assign mentors, and then we'll guide them and support them throughout the process of the project. And if you want to know a bit more information and of this master degree course, and then please scan the QR code for the more information, or contact our administration team directly, and they will answer your question. Thank you.
Perfect. Thank you, Lilian. Let's go to now. It's time for our Q&A session. Thomas, you have your hands up. Yes.
Hello, guys.
Hello.
I'm not sure if my camera is working. I'd just like to say a few words about Renata and her group's project. First of all, it was amazing what they were able to achieve, as I saw in some of the questions in the chat, especially talking about having previous coding background. The amazing thing that really blew my mind, as I had the honor to follow up with their development, is that they didn't really have a real background in coding or any expertise whatsoever. And as Renata were saying in her presentation and explaining the different machine learning techniques that they used, one thing that we should highlight is how they use different AI approaches. And one of them is how to actually use large language models like OpenAI or something like that to support your development and your learning process. As you can see, they didn't create like an AI agent or something that you fancy that you can see in a YouTube or TikTok video or something, but they really make make use of this technology to understand and learn things that they didn't know previously. Like, how can I create a training model? How can I code with Python? How can I properly develop and deploy a learning model or something like that? You won't be able to see like a typical chatbot per se. That doesn't mean that they didn't use large language models in this development. It's not only reinforcement learning, it's not only supervised learning, they use the whole broad techniques and tools available out there to be able to achieve these results. And it's really, really amazing thinking that nowadays you don't really have to have a previous coding background and still be able to achieve this level of excellence in developing a technological tool. It was really, really amazing and was really impressive of what they did. So then again, congratulations, Renata, and all your group, because it was a very impressive work development.
Thank you so much.
Yeah, I totally agree what Thomas say, and the course is quite very comprehensive as well, 1 year course, but the amount of knowledge you can learn and from like zero idea of AI and then get to the point you actually can provide the project and then with your own team and how to use the data daily you produce it from different software through the BIM and then through the construction project, and then you can use it to create a AI project, and it's phenomenal. Congratulations.
Thank you very much.
Well done, Renata, and your team. Well, really well done. So let's go to the Q&A session. Help me, please, Lilian and Thomas and Renata. We have a lot of questions here. People are on fire here. So, Renata, I think some questions are for Renata. One I saw just in the beginning of your presentation, we've got this one. Which AI model chat interface is being used? Can you use any of the AI, GPT, Gemini, DeepSeek, ChatGPT, etc.? Which AI model chat interface is being used?
Maybe the person wants to ask which large language model I used to learn programming. It was ChatGPT, but the AI model we made was made via Python script in Google Colab.
Perfect. And I will ask one for Lilian now. What level of BIM knowledge should the student have to be enrolled to the AI master program?
Well, to be honest, alongside you have like basic idea what the BIM means and then how to create the data from the BIM, and like obviously you need to understand how to use application for the BIM models and then BIM data, a lot of different software. I'm not going to name it, but like a lot of software you need to work on the BIM model, work on the BIM environment, CD, and you need to understand the basic knowledge and you are able to operate to use the software. Otherwise, is you cannot extract the data like Renata. So yeah, so foundation understanding you need to have it, and the basic knowledge of how to use program. You don't need to coding. You don't need Python, you don't need Dynamo, but you need a basic idea how to operate. And it's just not a Word and not Excel file you can know and email. That doesn't work, but you need a basic knowledge of application.
Perfect. Thank you, Lilian. Renata, is the AI able to detect valid penetrations, builders, work holes? So pipe work, ducts, and cable trays going through walls and ceilings?
The example of our project works only with beams and pipes, but it was just to get the minimal the minimal out of this problematic. But of course, if we were to evolve this solution, the goal would be to be able to understand those clashes between walls, ceilings. It's not so far developed as to this point, but if it were to evolve, it would be towards this type of recognition.
Perfect. Let's see.
About this topic, one thing that's very nice for the students to keep in check and try not get into the temptation is don't try to solve everything at the same time. Even though it's like a final course project, even though you have so many amazing ideas, try to have the discipline to choose only one thing and go as deep as you can to this one thing, because this is like a proof that you are in the right track and it's viable to develop something more complex in the future. But start with baby steps, you know. Choose a simple problem, see if it could be break down into even simpler definitions, and then starting from there. That's one thing that Renata's group made very well, this decision. Their initial idea was to create a clash detection classifier for literally everything. It could be accessed through a chat and large language model.
The original idea was to save the world.
Yeah. And then they start to breaking down and cutting down the access, you know. And because of that, I think they were able to go as deep as they did, and what it was shown here with Renata's presentation.
Great, Thomas. Thank you. Thank you, Renata. And let's see one more for Lilian, and then I will ask you if you want to give a message for our audience, okay? Because we have a lot of questions. Please connect with them on LinkedIn. You can ask them directly the questions, or if you have any doubt regarding our program, contact us directly. I share with you the link on the chat. So Lilian, or Thomas or Renata, feel free what kind of roles can you see coming out of doing course like this? Or do these roles already exist? Will the industry have to change or create new roles for people with such skills? I think you three can tell something regarding this, so feel free, okay?
Well, I mean, like, definitely, like, if you're thinking like 15 years ago or 20 years ago, we don't have a BIM, and then we have a BIM, and now we have a BIM manager, right? I will consider we have an AI manager in the future, or AI engineer for the construction industry. So that definitely will have a role for you. Don't worry. And because the AI is the way forward. And don't forget this. Don't forget this course is start in November. Okay, so when you graduate, it's like 1.5 years later, and that definitely there is some need in the market. So you try to advance yourself to learn that before other people, everyone's know it, and then you learn that, and then you will be ahead of the game.
Perfect. Do you want to comment anything regarding this, Renata or Thomas? Or okay, so now I would ask you to leave a message to our audience, and then we can finish the session because we are just out of time now. So Renata, if you want to leave a message.
I would like to thank everyone that took time to watch this presentation. I'm very honored to present my group's work. And if anyone, as Thaisa said, if anyone has questions, feel free to connect. And thank you, ZIGURAT, very much.
Lilian?
Yeah, thank you very much to attend this session, and I hope you understand a bit more what we can deliver. And don't forget this guys is learning like a couple of months, and then they have this valuable examples for you to look at. And in a 1 year's time and 1.5 years, and you will have a much better knowledge than now you got it now. So yes, don't be shy and don't be brave, and then take a look. And if you have any question, ask our team, and then our team will answer back to you.
Perfect. Thank you. Thomas, do you want to leave a message?
I would just like to thank everyone. Thank you for the presence. Thank you, Renata, for this presentation as well. And congratulations, was a very good work. And I guess we shall see each other later, maybe.
For sure. So congratulations again, Renata. It was really incredible, and you was amazing presenting this project today, and when you did it here at ZIGURAT. So congratulations. And that's it. A huge thank you to Renata, to Thomas, and Lilian for sharing their expertise today. And of course, thank you to you all for being part of this session. Let's stay connected. Don't miss our next events. And until then, take care and see you soon. Thank you and bye-bye.